Interesting. Here is another video to discourage you using unit circle. Why am I doing that? Well, 15 years of my experience have learned the students who start getting dependent on unit circle don't really understand how do we solve trigonometric equations. If this concept is not clear to you, please watch this video, right? And we have many such videos to tell you that's better to depend on basics, which are cast rule and special triangles, rather than the unit circle itself. So, in this video, we are going to solve many questions with unit circle and alternate methods. The choice is yours. Use the method you appreciate. Well, I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. And if you want to learn from me, send an email on globalmathinstitute@gmail.com. Our students are right there on top. They are the best joining the best universities. Great. So here what you see is set of 8 questions. We are now focusing on tangent function, cosecant and secant functions, equations related to these, and figure out how do we find solution of these simple equations using unit circle. Earlier we focused on sine, cosine and tan only. Well, unit circle does make some sense when we talk about sine and cosine. But what happens after that? That is what we'll explore in this particular video, right? So, as you see, there are 8 questions. Unit circle is given to you, and alongside, I've also provided the two special triangles. As you know, these special triangles are 30, 60, 90, right, in degrees, correct, and 45, 45, 90 in degrees. Those of you who are working in radians, for them, you know it is pi by 6, pi by 3, pi by 2, and pi by 4 is 45 degrees. Perfect. So now let us take up a question and then see how do we use unit circle to answer these questions. So the very first one, the simplest of all amongst reciprocal trigonometric ratios, is this question, which involves square root of 3 secant theta equals to 2. That means isolate secant theta, simple as that, and we get 2 over square root 3. Now secant theta is reciprocal of cos, so next step will be to rewrite this as cos theta and flip, and so you get square root 3 over 2. Now those of you who are using unit circle will go back to the unit circle and figure out the x values, right? So we know unit circle has x and y values, correct? Where the x value corresponds to cos theta and the y value corresponds to sine theta. So some students blindly go and check there are so many values on this, right? And which one corresponds to square root 3 over 2 for x. But before that, what is important to also see is the cast rule, right? We are looking for positive value of cosine. That means all are positive in quadrant 1 and cos is positive in quadrant 4. So we should look for quadrant 1 and quadrant 4 solutions, correct? So the only values which work out as square root 3 by 2 for x in these two quadrants, so let me mark these two quadrants, will be part of our solution, correct? So we figure out that, well, square root 3 by 2 is 30 degrees, right? So we see this x value positive, right? And here also we see this x value positive on the unit circle, and therefore we have two answers. One is this, which is 30 degrees, and the other one is 360 minus 30, I mean to say. Correct. So we got both our answers, and we say, well, theta is equal to 30 degrees and 330 degrees. Perfect. Those of you working with radians, for them, the answer will be pi by 6 and 11 pi by 6. Clear? So that is also given on the unit circle. So you learn basically how do you read the values from the unit circle. But that is not trigonometry, is it? Okay, anyway. But let us see how you should be answering this question some other way, right? Which is special triangles and the cast rule. So, beginning with again the same thing, we know that this cos theta is positive. Positive means we're looking for quadrant 1 and 4, and so we know that in quadrant 1 and 4 we have related acute angles, uh, which will give us the answer. So, we make this diagram, correct? And we want to find this related acute angle basically using a special triangle. So when you have something like square root 3, definitely you're looking into this triangle which involves square root 3, and that is your 30, 60, 90. Square root 3 over 2, cosine means you're looking for adjacent side, correct? So adjacent over hypotenuse, clearly the answer is 30 degrees. You can read, right? So you know that 30 degrees is your related acute angle. The other answer will be what? Well, the other answer will be 360 minus 30, which is 330 degrees. Clear? Easily you get this answer. You're not like finding a value and matching your answers from a given data, right? So I hope this concept is clear. The difference between using a unit circle and the basic concepts, the cast rule and the special triangles to provide you with exact solutions, right? Okay. Well, this concept will be absolutely clear as we move along in this particular video. I hope you like and appreciate it. Here's another question. Cosecant theta plus 2 equals to 0. Use the method of your choice, and then let's see again which is better. Well, in case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. So once again, the steps involved are: isolate the trigonometric ratio. We have cosecant theta plus 2 equals to 0, means cosecant theta equals to minus 2. Cosecant is reciprocal of sine, and therefore we can write sine theta equals to minus half. So once again, sine theta is minus half. You don't directly get into the unit circle, right? Sine is negative. First, you look into the cast rule. So one thing we are very sure of, that you don't jump into unit circle directly. You have to use the cast rule in any case, whatever method you use. Since sine theta is negative, we are looking for two solutions, and those two solutions happen to be in quadrant 3 and quadrant 4. Since sine is negative in these two quadrants, right? So that means we are looking for two solutions. One should be in quadrant 3, the other one in quadrant 4. You get the idea. Now, the second step is if you want to follow the unit circle, and fortunately, if it is given to you, only then you can use it, right? Then you look for y values. Once again, the x and y coordinates are given to you always in a unit circle where the y values give you the value of sine theta, right? So we'll write here again cos theta, sine theta. Now you know, radius is 1, right? So hypotenuse is 1. So the y value gives you sine theta. So you're looking for what value? Give me y as minus half. So there you go. You figure out, there you go. And once again, we find the solution, right? So we're lucky to get it. And so we get this angle and that angle as a solution, correct? And you can read directly from here, these two angles happen to be 210 degrees, right? 180 plus 30, that is correct. And this angle is 330 degrees. And you write down your answer. Well, it is 210 degrees and 330 degrees. That was using the unit circle with the cast rule, right? Now let's get to basics, right? which is always available to you, simple special triangles for exact solution of any trigonometric equation. Let's see. So what we have is 1 over 2 half. So we say, well, 1 over 2 means these two sides, and the triangle is 30, 60, 90. Sine ratio is opposite over hypotenuse. It is opposite to angle 30, and therefore we say, well, our related acute angle is 30 degrees. You see that. So, first you always find one related acute angle. Once you find that, then you get to the solution, right? Then the solution is in quadrant 3, right? This is quadrant 3, right? In quadrant 3, the angle is 180 plus 30. And then in quadrant 4, the angle is 360 minus 30, correct? So, these are the two solutions which you get using the special triangles straight away. Isn't that beautiful? So I hope slowly it's making sense, right? So once again, I'll recommend if you really want to go forward with trigonometry and be independent of given data and information, right? In that case, for exact solution, utilize cast rule and the special triangles shown here, and the method which I'm discussing is the best method to follow. Perfect. Now let's look into another question. So this time slightly difficult question. I have given you a factored form of an equation which is tan theta times secant theta minus 2 equals to 0. It really means that we are really solving two equations, tan theta equals to 0, right? And also secant theta equals to 2. Now, tan theta is sine over cosine, right? So, tan theta is a ratio of sine over cosine. So, as you know, when you are using the x and y values, let's get back to the unit circle for time being. So, this is cos theta, right? And that is sine theta. But you're now looking for tan theta. Okay, so tan theta basically is the value which is sine theta over cos theta, correct? So that means you're looking at the ratio of y over x, correct? So not directly reading the value. This time you have to find the ratio, and the ratio being 0. Fortunately, I've taken a very simple question, right? 0 means sine theta is 0, right? So basically, this means that sine theta is 0, correct? Basically. So y value is 0, so y value is 0 along the x-axis, clear? So that is how you will do it. And so you get your answer. The answer should be 0 degrees, 180 degrees, and 360 degrees. We're looking for solutions between 0 degrees and 360 degrees for all these examples, correct? Perfect. So we got one part of the solution, second secant theta equals to 2. That really means that cos theta will be 1 over 2. So half, and then, well, cos theta is positive in the quadrant 1 and in 4. So those who are looking into this circle diagram will look for when is it half, right? So it is half for 60 degrees. Okay, great. So that is the value of positive half and then this, correct. So you get these two answers. Cos theta is equal to half, and you write down your answers, correct. Good. Now look here, if you're not dependent on the circle, unit circle, right, in that case, you're looking into this particular triangle, correct? Cos theta is half, means adjacent side of 60 is half, right? So you know that the related acute angle is 60 degrees. So 1 is that answer, which is quadrant 1. And now you have to move to quadrant 4. So clearly, this answer should be 360 minus 60. Is that okay? So that is 360 minus 60. So we get two answers, one 60 degrees, the other one 300 degrees. Does it make sense? Did it take long time to use special triangles and the cast rule? Cast rule is common. You have to use it in both the cases, correct? Finding values? Is it easy? No, not at all, right? Great. So now you see when we are landing up with tan theta, you look into the ratio of y and x values, right? It's not easy sometimes, right? Now, if you look into these special triangles, so simple as that. Perfect. Now here we'll take another example, which is cosecant square theta, right? Now I think you are an expert and you can take your own decision which method to follow, which not to follow. Anyway, So let's go to this question now, which is 2 cosecant square theta minus 3 equals to 0. So we have cosecant square theta equals to 3 divided by 2, right? Okay, great. And then once we do that, then we have cosecant theta equals to square root 3 by 2. Now, when you land up with such a question, in that case, oh, square root 3 by square root 2, oh my god. So, and that too, we have to do both plus and minus, right? So, when you have both plus and minus, then in that case, what you have to do is none of these things can help you, right? Because for that, we do not have exact solution, right? So, we need a calculator. Is that clear to you? So I've purposely taken this question. Now you need a calculator. So in now if you need a calculator, what will you get? Right? We know that cosecant theta is plus minus square root 3 over 2. That means cosecant is the reciprocal of sine. So we have sine theta equals to plus minus square root 2 over 3, right? So we get sine theta as plus minus square root 2 over 3. We need to use a calculator for this answer. Now, all values, that means we have four solutions, right? We have four solutions. How will you answer this question? Well, clearly, you have to find the related acute angle alpha, right? Alpha, for which sine inverse of square root 2 over 3 is to be calculated using the calculator, correct? So let's use the calculator. Let me work in degrees now for the moment. I've purposely taken this example to show you that circles doesn't help, right? Unit circles doesn't help. We have to follow a proper way. So we do shift sine inverse, right? And then square root. And within the square root, we have to write down 2 divided by 3, right? So 2 divided by 3. And then we see what is it equal to. So we get a value which is 54.73. So I will write this as this angle as 54.7 for now. Is it okay? So we got one answer which is 54.7, right? So even a calculator gives you only one answer. We know clearly that in the domain of 0 to 360 degrees, how many answers are there? 4. How will you get all other answers? Well, clearly, as we have been talking about, the other quadrants, right, will give you the other answers. So your solutions will definitely be one we got, which is 54.7 degrees. The other one will be 180 minus 54.7 degrees. Then we have 180 plus 54.7 degrees, and then we have 360 minus 54.7 degrees. Does it make sense to you? So, this is the process which we had been doing with special triangles in previous four examples, and that is to be done as you move forward in trigonometry. Can unit circle help you? No. You have to understand the right strategies to move forward, otherwise, you will get stuck as most students do, right? So, now let's figure it out. We have 180 minus 54 point whatever. So, it was now I'm writing all the solutions. The first is 54.7 degrees, the other one is 125.3. I'll make it right. And then we have 180 plus 54.7, and that gives me in decimals gives me 234.7. Okay, very good. 234.7 degrees, and then we have 360 minus 54.7, and that gives me in decimals 305.3, right? All degree answers I've given. You can also work in radians, get your answers. You get the idea. So at this point, I like you to make a decision, right? And I hope you understand what is the idea of having this particular video. In case you really want to understand how do we do math in a logical and good way so that success is what we get at the end, right? Contact me at the given address. Perfect. We provide you with the best solutions. Great. Now, here is a question for you to do. 2 secant theta equals to secant square theta. We'll also discuss our approach in using the solution. But here is one thing which many students do wrong, which I'll discuss with you also. So let's rewrite this equation, which is 2 secant theta equals to secant square theta. We can write this as 0 equals to secant square theta minus 2 secant theta. Now, it's a good practice to keep the coefficient of higher degree positive. That is why I took secant theta to the right side. It is equation. You could write anything on left or anything on right, correct? So secant square theta, you can take secant theta common, correct? And so you get secant theta minus 2. And so now we have two sets of solutions. One, when is secant theta equals to 0. The other one is when is secant theta equals to 2. Now secant theta, can never be 0. Its value minimum is always greater than 1, correct? Or less than minus 1, correct? So no solution here, correct? In the other case, secant theta equals to 2 gives you cos theta equals to half, and we'll have two solutions, and both will be in quadrant 1 because cos is positive. We have used the cast rule, and in quadrant 4, correct? So we have two solutions for cos theta being half. If I look into this special triangle directly, I know my related acute angle is 60 degrees, correct? And the other angle should be 360 minus 60, so 300 degrees. And therefore, theta equals to 60 degrees and 300 degrees is my solution for this particular equation. Now, there is no need to jump into the unit circle, right? Even if it is provided to you, right? It is there on the side, correct? But do you want to use it? Ask yourself this particular question. Should you use it? Well, if it is given on the side, let it be there, right? And write down the answer, right? So, this is what my conclusion to the video is, and I hope you understand and appreciate what I'm saying. It comes from a person who has been teaching for 15 years. So many students come to me only to learn trigonometry. And one common problem which they fail to understand is what is next after unit circle. So initially, when trigonometry is introduced to them, they're fine. But as soon as they move on to the next chapter and unit circle is no more there, then what? Then they don't know what to do. They come to me, right? So here is what I'm telling you right in the beginning. Even if unit circle is given to you, think over it. Sometimes it is good to know, is too good to know. With that, we'll end the video here. I hope you understand and appreciate the idea of this particular video with these beautiful examples which I took for you. Correct? We were focusing on 0 to 360 degree solutions in this particular video in my playlist. We'll have many types where we are taking unit circle also just to discourage you, by the way, to use unit circle and to encourage to use the special triangles along with the cast rule, which you have to use in either case, right? And also, look, how do we provide general solutions for these equations? With that in mind, have a great day. Thanks for your time and all the best.